Hi, my name is Steven Jackson, and this is my speech of definition. Good afternoon, ladies and gentlemen. Thanks for taking time out of your busy schedules after your fall meeting to talk about chemistry with me. As a chemistry major back home at the University of Central Florida, stoichiometry is one of the most basic principles I have to understand in order to build upon it and go into all the advanced, methods and techniques in chemistry. How many of you have heard of stoichiometry? You, and could you tell me what you think it means?
I think it has something to do with ratios.
Ratios, gotcha, yes. If I had a Expo marker, I'd totally draw it on this whiteboard, but I don't. So if you look on your sheet that I handed you, you see a chemical reaction at the bottom, and it says 2 zinc solid plus 2 hydrochloric acid, which is HCl, yields hydrogen gas and a solid called zinc chloride. And this is actually not the easiest chemical equation. I don't know why I used it, but this is a direct representation of what stoichiometry is. Stoichiometry first takes information that you have on the periodic table, which you guys all know what that is. You have, say, hydrogen is your first element, and under each element you have a number, and it's called the molar mass of your element. And first, a mole is the most basic unit of measure in chemistry. So you take 1 mole of hydrogen, and it's kind of imaginary, but not really. So just think of it as an imaginary 1 mole of hydrogen, and it weighs 1 gram per mole. So each element has its own molar mass, which we then use in the stoichiometry. The only other thing that you need to know for stoichiometry is the balanced chemical equation, which I showed you. You have 2 zincs, 2 hydrochloric acids, and then you only have 1 hydrogen gas and 2 zinc chlorides. So that's all stoichiometry is. You take the molar mass of the number, or of the atom of the element from the periodic table, and you plug it into the balanced equation, and voila, that's the basic chemistry that you have to know. And then I wanted to talk about an experiment that I did the other day in chemistry because it was really fun. What we did is, notice your page is titled gas stoichiometry rather than just stoichiometry, and the only difference is you use gases instead of solids. And we did this experiment. I'm in the Chemistry 2 lab back home in Florida, and we needed to come up with, because car companies are tanking right now, we love how Chrysler's just going downhill, and they were looking up a cheaper way to fill airbags rather than whatever they use now. I'm not sure. But, so we were researching what is a cheaper gas to fill airbags with, or a cheaper materials. And we actually determined that, okay, first we had to determine how much volume was in this plastic baggie that we were going to then inflate really fast to save your head from hitting the windshield. And we poured water in it, so it was really cool. And so we got the volume, and then all you do is you pour something called acetic acid, which you all know what that is. It's vinegar. It smells really bad. And then sodium bicarbonate. They're 2 liquids. You just pour in there together, and the bag inflates really. You have to zip up the bag. It inflates really, really slowly. So we thought, this is great, because, reduced population, because the airbags will deflate so slowly that people will die in car accidents. And the big 3 will, have a cheaper way of making airbags. So it was pretty amazing. So again, the definition of stoichiometry, the way I wrote it is, it refers to the coefficients in the balanced equation, the 2 zinc and the 2 hydrochloric acid, between the reactants on your left-hand side of the equation and the product on the right. And I also quoted a guy named Gabriel Lapidus from a journal. His article is called Kinetics and the Stoichiometry of Gas Phase Decomposition of Oxalic Acid. The reason I quoted him is because he was doing his PhD research on some crazy, complicated decomposition, and all I saw in there was something about like 2 hydrogen gas goes to like, or maybe he used water. He had something very simple in there, and that's the only reason I quoted him, is because no matter how complex you get, you still have to be super, super simple. So that's why I love him. Again, thank you all for listening to my spiel about chemistry, and I hope you all have a great day here in Massachusetts.